Hi guys, so this week we are doing chapter 9, which is still audit sampling, but it is audit sampling for substantive testing. So we are finally with this chapter moving into the realm of substantive testing. With respect to determinants of sample size, when we're talking about substantive testing, there are 4 important determinants, and the first 3 are basically what we've seen before, right? Confidence level, tolerable misstatement, which was our tolerable error rate, expected misstatement, which was like our expected error rate in TOC, and lastly, population size. This is new for substantive testing, right? Because when we did test of controls, population size typically didn't come into play unless the population was relatively small. But now with substantive testing, it is typically quite important, which makes sense, right? Like the materiality of an account balance should be important because we know if a balance is relatively immaterial, it would make sense that we would want to test it less than if a balance is highly material. And the idea behind sampling with substantive testing is that we want to come up with some kind of estimated misstatement in this sample, and then we're going to be projecting that across the population. But we still have to think about sampling risk. So there's this quick example at the beginning that basically has this idea of using a sample or sampling a proportion of the population with substantive testing and then projecting that across the population. So let's say I'm testing inventory, and there's a $3 million inventory balance, and I'm only sampling 100K of it. So 100K is the book value of that balance. Then 98,000 is actually the value I find when I'm testing. So I say 98K is essentially the true value of these items. 100K is the book value. So the error rate in my sample is this 2K. So in other words, 2%, right? Because I'm going to divide the 2,000 by the book value and obtain a 2% error rate. Now, if I'm going to do what it talks about here and project the misstatement I found in my sample across the population, all that means is I'm going to take my 2% error rate and project it across the population I was testing. So I would multiply 2% times 3 million, which is the total book value of inventory, to get a 60K projected misstatement. And that is all fine and good, but it does not include an allowance for sampling risk. And if we think back to chapter 8 and attribute sampling, when we talked about the upper deviation rate, that included an allowance for sampling risk, right? And it also included the sample deviation rate. So we want to do something similar or be able to come up with something similar, but using dollars. So basically, we want to come up with some sort of projected or computed upper deviation rate in dollars that will include both this 60K and also include some allowance for sampling risk. And the reason why we want to do that is so we can compare that upper deviation rate in dollars to tolerable misstatement. Because otherwise you get into situations like this, where we say, okay, we have this 60K projected error, and let's say TM is 50K. Okay, that's easy. 60K is bigger than 50K TM, so I know the account's not fairly stated. But what if I have 60K projected error and TM is 65K? Now I'm kind of left in this no man's land where I don't know if my account is fairly stated or not, because I know TM is 65K, but I don't really have a sense of what the, I'll say computed upper deviation rate for now, what the computed upper deviation rate would be in dollars, right? I know that the sample deviation rate is 60K, but there's no allowance for sampling risk built into that number, right? This is really the kind of factual amount of error. This is similar to my sample deviation rate in tested controls. So no allowance for sampling risk in there, no allowance for the fact that I might have pulled a bad non-representative sample. So I need some way to account for this, really, in order to be comparing a number to the 65K. And that is what we're going to be spending a lot of time on today with monetary unit sampling. That is what monetary unit sampling allows you to do. It's using attribute sampling theory to essentially calculate a computed upper deviation rate in dollars. Popular applications for MUS are AR and inventory. According to your book, inventory is also a popular one. I will tell you guys from personal experience, what I saw MUS used for in practice was AR, and specifically for selecting AR confirmations, like which accounts receivable accounts are we going to send out to be confirmed. Inventory, I did not really see MUS being used, and I feel like if it were commonly used in practice, I most likely would have seen it, because since all my clients were manufacturing, inventory was always a very, very significant account, and we always did a ton of testing of our inventory. So it seems like maybe that MUS isn't quite so commonly used for inventory, but I definitely saw it pretty frequently being used for AR. All right, and one thing to remember with MUS is in MUS, every dollar in a population has an equal probability of being selected. All right, so when we were talking about test of controls, if you were doing random sampling, you would have said every transaction in this population, right, or every invoice or every shipping document has an equal chance of being selected. But in monetary unit sampling, it is every dollar unit. And if a particular dollar unit is selected for testing, then the entire balance related to that dollar unit will be tested. So if I pick a particular dollar for testing in the AR balance, I'm going to pick that entire customer's account to test, right, or to send out the confirmation for. What that means is, because each individual dollar has an equal probability of selection, this means MUS in general is going to bias towards the selection of larger balances. And you can see why this would happen, because larger balances will have more dollars in the sample. And if every dollar has an equal chance of being selected, then if I'm a larger balance and I have more dollars in the sample, then I've got more representation in that sample, right? And so more of my dollars in there, so it's more likely that one of my dollars will be picked, rather than if I'm a small balance, I have very few dollars in the sample, so less chance that my balance will be selected. And so because of this, MUS is also called PPS, or probability proportional to size sampling, because your probability of selection is proportional to the size of the balance. What that means in practical terms is that because those larger balances are more likely to be selected, you will wind up selecting, on average, larger items, which will wind up getting you overall a sample that has a larger coverage of the population. Because I'm picking larger balances overall, I'm going to wind up, my sample will be covering more of the population, but I'm also maintaining randomness of selection, right? Because I'm not judgmentally picking the larger items. And like we were saying earlier, MUS is using that attribute sampling theory to express a conclusion in dollar amount, right? So you will hear me talking a lot today about how basically we are using the same underlying theory and we're coming up with a computed upper deviation rate in dollars, okay? But it's all the same underlying concepts as what we talked about in chapter 8. All right, one thing that is different is in attribute sampling, we tended to conclude a control either works or it doesn't, right? More of an all or nothing approach. Whereas in MUS sampling, a small deviation, right? So if I record this invoice slightly off, it doesn't count as 100% error, right? So small deviations do count as small, bigger deviations do count as bigger. So it's less of this all or nothing, control worked or didn't work type of mentality. And the point of why we do care if it's a small deviation or a large deviation is because ultimately we want to use the amount of the deviation to help us kind of project the error rate across the population to really get a best estimate of the population misstatement. Okay, so quick multiple choice question for you guys. Please take a pause. All right, so hopefully you're back now and you've selected your answer. So the question was just, which of the following is not true with respect to MUS sampling? First is every dollar has an equal chance of being selected. All right, so we just said that this is true. Every transaction has an equal chance of being selected. A and B are kind of diametrically opposed here. One can't be true if the other is true, so I know one of these has to be true. And this is true for attribute sampling with TOC, right? But it is not true for MUS sampling. So it's looking like B is my probable answer, but I will keep reading. Okay, C is higher dollar value items have a higher chance of getting selected. Yes, we said that's true, and that's why it's also called PPS. And a small deviation in dollar amount is not going to count as a 100% misstatement. Yes, because ultimately we want to be able to use that error rate to project across the population and develop some kind of estimate of rate of error. Okay, so answer was B. If you struggled with that or didn't get it, that was a pretty straightforward question, so it might be a good idea to go back to the beginning, rewatch till you feel like you were on board and get that question. So some advantages of MUS. When you don't expect to find a lot of misstatement, so when you have a low sort of expected misstatement or expected error rate, then you'll usually wind up getting a smaller sample size than if you used a quote-unquote more traditional method of sampling. When it says more traditional, it means like classical variables sampling using random selection. And part of why this will occur is because of this idea that we talked about, that because it biases towards larger balances, you will wind up testing a bigger chunk of the population, so you'll get more coverage. The second advantage is MUS doesn't require the user to make assumptions about distribution of misstatements. All right, and again, this is an advantage relative to classical variable sampling. And classical variable sampling would have been what you learned in stats class, right? So you probably talked about how you have this underlying assumption that errors are normally distributed through the population, how they are mean zero, things like that. You don't have that type of thing as an underlying assumption in MUS. Actually, with MUS, you tend to assume that overstatement is the issue. And so it tends to assume that the errors are going to be over on this side of the distribution, which we actually see over here as the number one disadvantage of MUS. Okay, so if you are concerned about zero or negative balances, you would want to do some sort of special design. And really, you wouldn't really want to do a special design. It's more so that you wouldn't want to use MUS if you were really concerned about zero or negative balances. So what this means is MUS is really good for tests of existence or tests of overstatement. It is a really bad test of completeness or test of understatement. And if you think about this, it makes sense, right? Because with MUS, going back to this earlier slide, every recorded dollar has an equal probability of being selected. I know it didn't say recorded here, but it kind of goes without saying. So every recorded dollar has an equal probability of being selected for the sample, but obviously unrecorded dollars don't have a chance of being selected for the sample. So MUS is not a good test of completeness. Only positive dollars in the sample are going to be having that equal chance of getting picked. Number 2, so the general approach to MUS assumes that the audited amount of the sample item is not an error by more than 100%. This kind of goes along with number 1, and really what it means is if I have an accounts receivable balance of $3,000, MUS assumes the true value of this AR account lies somewhere between 0 and 3,000, aka the misstatement is somewhere between 0 to 100%, right? MUS does not assume that the balance of that AR account could be negative 200. It doesn't assume the balance of that AR account could actually be $6,000, right? And so this is just kind of an underlying assumption of MUS, is it doesn't really allow for these kinds of possibilities. Its assumption is, okay, if it says 3,000 on the balance sheet for this AR account, it's somewhere between 0 and 3,000, right? Because what we're really concerned about is overstatement. And number 3, when more than a few misstatements are detected, the way that you calculate, it says here the sample results, but it's basically the way you calculate the upper deviation rate in dollars might overstate the allowance for sampling risk. And this will make the auditor more likely to incorrectly reject the balance and think it is materially misstated when it actually is not. And for number 3, we can better see why this happens when we later actually are doing the calculations. It becomes a lot more clear. It's kind of difficult to explain this one without doing the calculations and seeing the calculations at work. So you kind of have to trust this is true for now, and then later you'll see in the calculations themselves, it'll make more sense as to how this could happen.